Okay, continuation from the last two videos. So in the first one, basically I described all the conversion and optimizing of over 934 objects, and then reducing the poly count through retopology. And then now we're to the point of why we retopologize things. And so what you're seeing here is the forearm musculature. I'm currently working on the intrinsic muscles of the hand, so those will come next and they will go in there. And then I'll be done with the upper extremities except for working on the back. And the back muscles are going to be a pain in the butt, but we won't get into that right now. Um, what you're seeing here is that the forearm muscles are basically the composite parts that were included are about 24 muscles, I believe. And it says there's 27, so there's probably 26 muscles and one interosseous membrane in between the radius and the ulna. And when you start adding in things that are made up of tens of thousands of polygons and you're trying to keep track of that in several different areas, tens of thousands end up becoming millions. And so what I have here is just 21,000 faces that make up all those objects. Now, if I were to bring them in individually in those high resolution forms, I think I get up to over 350,000 polygons. So that's quite a bit of a reduction. Sorry, I'm going a little bit retarded on my speech. It's a fair amount of reduction. So this is how it gets reduced down into, and I showed you that before. And then this little purple map here, let's get rid of that really quick, is called a normal map. And you'll notice something. It's a little bit, well, striated, just like striated muscle should have. Well, this is actually the high resolution brachioradialis muscle here that was basically kind of scanned with a certain type of algorithm and another piece of software. Blender can do this as well. It's just a pain in the ass to do it, and plus when I do it in the other software, then I actually paint onto it. And so when we go ahead and paint most of this stuff in here, it ends up on when I paint the color map, kind of looks like that. Not really, not when I'm looking at it, but that's what it looks like. So let's see if I can bring this up really quick. We might be able to show you what the baking process looks like on something else. But I'm not going to go through and paint this part because I like to do it. I know I'm kind of anal. I like to do all the parts together and then assemble them together. So I'm not really going to show the entire painting process and how I texture it just in this one here. When we get to the point where I'm actually assembling all the stuff together or trying to, or when I'm done modeling or retopologizing, I think I only have two more parts left, and the intrinsic muscles of the hand. Then I'll show you how I paint just one part, but here's the baking process. So we're in Substance Painter, and so I'm going to use one of those items. And I'm going to do a new project. I have to change some stuff here. Let's just keep that same thing here. So what I'm going to do is take a look at the, what was I working on? Oh, let's try the Flexor Pollicis superficial head. Okay. So it'll bring it in here, and this is what it looks like, and it looks the same as it did in Blender. It's just lit a little bit differently. And so what I do is I go in here and I bake textures, and these textures are used just inside this software so that when you do paint things onto here, it knows basically where to place all that stuff a little bit better by using these types of maps, and you can use those maps as masks and so on for different effects. Basically I'm just going to take baked textures. I'm going to increase this one just a little bit here. You guys don't need to know about that right now. It's just where it seeks out the surface, and it looks at the high poly mesh to bake down to this. So the high poly mesh you'll never see. So we'll look for the file, and right now I have the Flexor Pollicis superficial head, that's the low resolution, so I need the high resolution stuff. So let's look for the high resolution, that one. And then because I gave it a surface name, it's always important to give this a surface name. Because if you don't, it'll just say default for all of them and you'll have to rename all of them. So let's bake it. So right now it's going through and it's looking at the high resolution stuff and it's baking in all the information that it needs to create the map for here. And it may or may not do a good job. You know, sometimes they need to do it several times. And there we go. We get the high resolution information baked down onto this low resolution image. And so it was that easy. This is fake. It doesn't exist. The low resolution is still there. As you can see, it's still faceted. When I look at it on edge, there isn't really anything there as far as bumpiness. It's all a lighting trick. So let's go into here. I think iRay renders this here, and so as you can see, as it just, you know, renders this out as if that geometry actually existed. And then on top of that, you can paint whatever you want. You know, I could change the color of this really quick and just show you that, you know, you paint on it. You can do fills and stuff like that. I'll show you all that stuff later, but this is how we get that purple image. That purple image resides right down here. Okay, same type of thing. Okay. So anyway, there's that purple image, and we did that for every single one of these things. And we unwrapped this like I tried to explain before with the seams. We unwrapped it. It created a UV map. What that looks like is this. And so it sits in these UV coordinates. The X coordinate and the Y coordinate is called the U coordinate, and the V coordinate. So it's not confused as the X, Y, and 3D space. Blender has a little bit different approach to coordinate systems, is that this is on the ground. The Y is on the ground. Usually the Y is pointing up and the Z is on the ground. But whatever. And so our normal map sits like that. So everywhere these vertices are, is they're kind of describing their location in UV space and where to project that particular part of the texture onto this model. And so again, with the color, looks like that. It's not a very efficient use of all this real estate, but you know, what can you do? I could have put more stuff on there, but I like building these individually and then putting them together as a group eventually. And so all these things have to have a place to go. And so this is a node network which defines things, and node networks are a very good graphical representation of what's going on in here for surfacing. And so you this is where everything gets compiled. It goes from left to right, but you read it kind of right to left is what's going on here. So this is the output part. We're eventually going to end up over here. We have something called a shader, which actually defines how this thing looks and shades it inside of the render. We have that normal map, which is the purple part. So we have to have this read it and put it in, and we can define the strength of it here. And we put that map, the purple map, is actually living right there. And this color map is living right here. And so you just take the color and we put it in the base color, and we put this color here, and we do the normal, and we define the rest of this musculature through this shader that defines the overall quality of this, or the appearance of this part. And eventually all that missing detail, because of retopologizing things, comes back in the renderer. So let's render this. And there it is. Here's all that detail that we had, that we baked into it. And we're using image maps. And the thing about image maps is that all this extra information comes for, and let's just put it in quotes, free. Because it does have to load these in individually onto the video card because I'm using GPU rendering right now. So basically it is kind of a free ride in getting all this information because you're not adding in all the geometry, all the vertices, all the information that they had to carry. We're only dealing with a limited amount of vertices and a node network to do. Got a little glossiness there. We got 0.4 there. We can also give it a little clear coat. We could also define the normal, and that clear coat will be right there. And then there's subtle changes that happen. But there is one thing that I didn't like, and is it not showing up? I must have fixed it on here, and I don't know how I fixed it. It would be nice to know, but I did. There used to be on this right here, and I don't know what was causing it because there's nothing that I really. Let me seek it out. There was an artifact that was on this geometry right here, and I think, that's weird. That created a little problem right around here, and didn't create that problem for RenderMan. I don't know why. See, none of these have its subdivision surface properties on it. Let's try to subdivide that once. All of these should have that subdivision surface modifier, but it didn't really need it to get all that information there. Maybe I did have something. No. I should move all these to the top first. So there are some little things that I skipped out on that I should probably work on. The subdivision surface modifier will actually make it look a little bit smoother. And basically by moving these up, I'm telling it to subdivide before mirroring it over. But yeah, the faces get a little bit more and more heavy when you do that, and I don't really need it too much to define this, but that's where I was going to start with. But things start to pull away from one another, the gaps get a little bit larger because how subdivision works. So I may not even subdivide it. How the polygons are laid down in the smoothing, I may not even need to do it, but I must have fixed that artifact, and it's bugging the crap out of me for, geez, a long time. I don't know how I fixed it. It's still kind of there. Yeah, it's right there. So there's a little artifact in here that doesn't work too well. I'm going to show you in RenderMan that same muscle, how that turns out. So let's just do a little pause, and then I'll bring up the RenderMan version of that.